In this video, we're going to look at distance time graphs. You need to know that distance time graphs represent a journey, and the vertical axis represents the distance from the starting point, and the horizontal axis represents the time taken. Okay, if you want to work out the average speed, you need to divide distance traveled by the time taken. When you see a graph, you need to be able to interpret and read the information from it. Okay, when you see a straight line going up, okay, that means that the person started the journey and is traveling somewhere. Okay, a straight line means steady speed. Now, the gradient of those lines can be different. So you can see I have the red line, which says steady speed, and then I have a green line, which also says steady speed. Okay, that is because we have straight lines. However, the difference here is that the steeper line, so with the higher gradient, will have a higher speed. So the red line represents higher speed, and the green line represents slower speed, slower movement. When you have a flat line, so a horizontal line, okay, that means the person is stationary. That means that the person is not moving. Okay, and then a line going down, okay, straight line going down, that means that somebody is moving at a steady speed but returning to their starting position. So let's have a look at how to work out the speed from different times graph, as it is a very common question involving distance time graphs. You need to remember how to work out the speed. Okay, the formula, okay, for speed is distance divided by time. So you need to read the information from the graph. Okay, distance goes along the y, okay, or the vertical axis. So I can see that the line stops here. Okay, so the distance is 3,000 for the first question. Okay, 3,000 over, now time, I go down to read the time. Okay, that is 3. Okay, so that is 3 hours. So 3,000 divided by 3, that is 1,000. Okay, and that is kilometers per hour. In the next question, I need to work out the initial speed. Okay, that means I'm only interested in this part of the journey. Okay, so this diagonal line going from 0 to 60, okay, and then to 30 on the horizontal axis. So again, speed equals, now the distance is 60, okay, then time is 30, okay, so that is 2 meters per second. Okay, and in the last question, I need to work out the average, okay, speed. And to work out the average speed, I need to divide the total distance by the time taken. Okay, so the line stops here. Okay, so that means that the distance is 30, and that the time taken, okay, goes down to here. That is 5, so that is 6 kilometers per hour. Okay, remember about the units. Now we're going to try and match up some descriptions of journeys to the graphs. Okay, these ones are quite straightforward, but it's just to show you how you can take the information out of the text and then represent it on a graph. So I'm going to start off with this expression, description here. So I have Joe walked at 4 miles per hour, okay, for 30 minutes, and then sprained his ankle. Okay, so I know that he walked for 30 minutes. So this is the bit of information I'm going to take out, and I'll try to decide which graph, okay, actually represents this journey. So I can see in the first graph, the first part of the journey, okay, it actually takes up 30 minutes. Then the next one, okay, goes up to 40. So that's probably not what I want. Then the next one goes up to 50, so probably that's again not what I want. And the last one goes up to 30 again. So I'm interested in graph A and D. I need to decide which one is the right one here. So I'm going to read a bit more. After getting treatment for 30 minutes, okay, so that means that Joe was not moving, okay, he was not walking for 30 minutes. So the next part of the journey needs to take 30 minutes. In graph A, it's from this part here, okay, because this means not moving. It's from 30 to 50. That's only 20 minutes, okay. For D, it's from 30 to 60. So that is 30 minutes. So I know that this journey is represented by graph D. Okay, the next one, okay, about Anna. Anna jogged 6 miles in 40 minutes. Okay, 40 minutes straight away. I can see that that's going to be graph B. Okay, because that's how long the first part of the journey took. And then after resting for 10 minutes, I'm going to see whether that is correct. That is correct. Okay, that's only 10 minutes. Okay, she walked 2 miles at 6 miles per hour. I could calculate, okay, the distance and check whether it's correct, but because I don't have any extra graphs or extra descriptions, I know that all of those need to be matched up. Okay, so that first piece of information, okay, was very, very helpful. Now, the next one about Chris. Okay, Chris covered 2 miles in 50 minutes. Okay, in 50 minutes, I know that the first bit of information, that's the first bit of information. I know that the first part of the journey needs to take up 50 minutes. So I know straight away that this is graph C. Then he started jogging after 20-minute break. Okay, so this is the break. Okay, 20-minute break. Okay, and then he continued running. Okay, so that means that the last description must be for graph A. Let's have a look. Sally ran at 8 miles per hour for half an hour. Okay, half an hour, that is 30 minutes. So that is correct. Okay, rested for 20 minutes. Okay, that is also correct. She rested for 20 minutes, then continued walking at 4 miles per hour. Okay, now as I said, you sometimes need to actually calculate some more values from graphs or from your description to be able to plot a graph. We already looked at how to work out speed, but sometimes you may need to be able to rearrange the formula to find some other measurements like the distance or time. In this example, we have to plot the graph from scratch, so we have some information and we need to use it to represent the journey on the graph. So Anna goes on a car journey. For the first 20 minutes, her average speed is 45 miles per hour. Now you need to spot, okay, that the time is given in minutes and then the speed is given in hours. Okay, so we need to convert the time into hours. 20 minutes is 1/3 of an hour. Okay, you know that there's 60 minutes in 1 hour, so 20 out of 60 is equivalent to 1/3. Okay, speed equals distance divided by time. So if I want to work out the distance, I need to multiply speed and time together. Now I need to work out the distance here because I need to know how high my line needs to be. Okay, so to work out the distance for the first part of the journey, I need to times speed and time. So the speed is 45 and the time is 1/3. So that means it's 15. So it's 15 miles. So that is the distance for the first part of the journey. Okay, so I can now draw the line. I know it needs to go up to 15 on the vertical axis and then up to 20 on the horizontal axis. Okay, so you can see it goes up to 15 and then up to 20. Okay, Then she stops for 20 minutes. Okay, she stops. That means I need to have a horizontal line for 20 minutes. So that's from 20 minutes needs to go up to 40. Okay, I can draw that line. Then she completes the journey at an average speed of 30 miles per hour. Now notice that she's not coming back. Okay, she continues with her journey. Okay, so my line will not be going down, it will be going up because she carries on with her journey. Okay, now I also know that the total for her journey was 1 hour, the total time. Okay, so I know that the last part of the journey took 20 minutes. Okay, but I need to know how far she went. So this time I need to work out the distance again. Okay, but the speed, okay, is 30 miles per hour. Okay, 30 miles per hour. And again, the time is 20 minutes because that's from 40 to 60, which is 20 minutes. Okay, so now the last part of the journey, okay, speed times time. The speed is 30. Okay, it's given in the question, and the time is a third. Okay, because that's 20 minutes, and 20 minutes is equivalent to a third of an hour, so that is 10 miles. Okay, so I need to draw a diagonal line going from 15, okay, plus 10, so it needs to go up to 25 on the vertical axis and then up to 60 on the horizontal axis. And that's my graph finished.